now I can start. I'm sure half of you are here. Just give you a rundown of what we are doing because and what we've done so far. I'll just give you a run um, up on this. Oliver, your legs. Oliver, okay, I'll allow you. 1 minute is not really big deal, so I'll allow you. The rest of them, you can have the leg list. Okay, so we have covered so far. Let me look in my syllabus. When we started this unit, chemical reactions, we have covered, what is a chemical reaction. We looked at examples, the indication symbols that show that chemical reaction has occurred. We've looked at that. Um, we've looked at a couple of examples, which was a combustion reaction. We looked at oxidation. We looked at thermal decomposition. Um, we also looked at endothermic and exothermic reaction. All of these were covered already. We looked at last lesson. We looked at okay, um, and we also looked at balancing equation. All of this, you need to have the notes for that because when the test time is up, you need to use it to revise. And today we're looking at acid and alkalis and neutralization reaction. Right? I'm sure you know. I mean, this you've had lessons on this in year 7, isn't it? So some part I will not spend too long on this. Okay. If you've had lesson on acid and alkaline year 7, can you type yes in the notes so I know if I should go to the basics or I should go to the alpha level? So let me know if you've had lessons on this. Alkaline says yes. Right, let me know. Right, have you all had lessons on acid and alkaline? So I'm just going to skip all the way to the neutralization part to let you all know. Okay, if you say yes, that's good. That's good. Right, let me move on. Right, good. Says good. Right, so I just brought this diagram here to just make you aware of these. Laboratory. If you in laboratory, this is what you see acids. Okay, it's all labeled, so you can see the labels there. You can see the beaker there. You can see the volumetric blast, volumetric, yeah, all of that, and conical blast, all of this. They all signifying solutions or acids. Okay, Fahim late. Right, so Fahim, I'm right, I'm giving you the list. Okay, so I just brought this diagram here and then just kind of safety precautions is you wear gloves when you're dealing with these type of things because acid can be corrosive, which I'm sure you know this already. Okay, so what do vomit, vinegar, and lemons have in common? What do they have in common? Do you wanna type in the chat box? Let me know what do vomit, vinegar, and lemon have in common? It's a key word they have in common. What is it? Who can type in the chat box? Let me aware. They have acid. They have acidic. They have acid. Okay, they all have acid. But then there's a word. There's a word. It starts with S. That I mean, all of you are saying they have acid, which is good. They what's the word? Sour. Isn't it? You know how you say it. It is like sour, something like that. So yeah, they all taste sour, and because they contain acid. Okay, and vomits include acid from the stomach. What acid is found in the stomach? In year 7, you would have heard of this. If you've not heard of it, I will have to contact Miss Saunders. What acid is found in stomach? You've done digestive system with Miss Chalice as well. You might have come across this as well. What acid is found in the stomach? Wow. It said sulfuric. Who said sulfuric? It's Mohammed. Is it it's not iron, it's Zephyr, I think. Zephyr, is that you? If you actually want me to go and mention Miss Callister and Miss Saunders, that sulfuric acid is found. Okay, it's hydrochloric acid, okay, HCl. Right, so know this. Okay? Don't ever be confused like that anymore. Okay? Right. I didn't expect this from anyone actually. And from you especially. Alright, so hydrochloric acid. Vinegar is a solution of acid as well. Lemon contains acid, okay? All of that. So now acid then. acids are a group of chemicals. Okay, they're a group of chemicals. Um, so they are found in household items such as food, drinks, beauty, skincare, and stuff. So everyday acids like lemon, vinegar, orange, tangerines, all of these contain acids. Okay, can you think of any examples and any acidic examples? And these are the acidic ones we have in the lab: hydrochloric acid, sulfuric acid, nitric acid. These are all the acids we have in the lab. Can you think about everyday acids that we come across? Any idea? Some everyday acids. Anyone want to give example? Anyone? Give some examples of acids that we come across every day. Okay, I'm sure no one knows anything so far. Okay. All right. Okay. Sure, no one knows anything. And what is weak? Oh, citric acid. That's correct. Saliva. Yeah. 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 It contains that as well. Yeah. That's right. Okay. So what is weak acid? What is a weak acid? If I say this acid is weak, what is it? Does anyone know? This one is just a revision lesson actually, because you know this already, isn't it? You've heard of this in year 7. So I won't spend too much long time as much. That's correct. Acid. Yeah. So I mean, what all of you are saying is correct. So some acids are found in everyday items such as food, drinks, and skincare. Okay. So these acids we call them what? It's safe to handle, isn't it? Yeah. So these type of acids are what they known as what? Weak acids. Okay. Um, like what you're saying, the pH level is 5 to 6. Yes. I would normally say from above 4 pH 4. So pH 5 6. So between 4 and 6. That's what I'll call weak acids. Okay. Their pH is between 4 and 6. Okay. So yes. You've also said the key word there, Afana. That's what I wanted to hear. The pH scale. So, but then essentially, the weak acid is just our everyday acids we see, okay, because they're easy and safe to handle and contain. So that's what we know as weak acid. What about strong acids? Strong acids like the laboratory acids, okay, hydrochloric acid, um, sulfuric acid, nitric acid, laboratory and carbonate acid. They're very dangerous, too dangerous and too to touch and to taste. Okay, to touch and to taste. So these type of acids, they are called strong acids. Okay, these are said to be corrosive. That basically means they can, damage you, isn't it? They can damage um your skin or so. So be very careful. This is why must strong acid always be handled very careful. That's basically because they're corrosive. They're dangerous. That's the reason. So you need to be careful handling them. So that's why when you're in the science lab, we always tell you pay full attention. Do not play because we're dealing with a lot and lot of strong acid. pH scale. Sorry. The pH for hydrochloric acid is around 1. Which is very very strong acid. So do not ever play with it. Okay. You know this already. So now you know the difference between strong and weak acid, right? You know what an acid is, okay? Good. An alkali. So an alkali are another group of chemicals. They're opposite acid. So alkali is opposite acid. It's safe to handle these alkalis, which confuse of you. So these are known as weak alkalis. So it's just like the acids as well. We have weak acids and strong acids. We have weak alkalis. So example like soaps, your soap that you use at home, your toothpaste, your paracetamol, all of these are alkalis. Okay, they're weak alkalis because they're safe to handle, isn't it? So anything that is safe to touch is considered as weak, and then anything that is really strong is not safe to touch. For example, strong acid here, strong alkali, sodium hydroxide. Sodium hydroxide, if you can see here. So these are examples. I'm sure you're making notes whilst I'm talking, okay? I'm sure you're making notes. You're following up with me because I'll be expecting some of your work at the end of the lesson. So, sodium hydroxide is a strong alkali. It's normally used in the lab. So again, you need to be very careful of it. Okay. Ammonium hydroxide. So sodium hydroxide. Who can tell me the formula for it? Sodium hydroxide. What's the formula? Sodium hydroxide. Who can tell me? Who can tell me? Sodium hydroxide. Listen, the O should come before the H. Okay, NaOH. 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 So it's NaOH. Sodium hydroxide. What about ammonia? Tell me ammonia one. Does anyone know? Ammonia hydroxide. I wouldn't expect anyone to know this specify. If you know, that's good. It's NH3OH. Okay? NH3. Ammonia is NH3. Okay, OH. Hydroxide is always OH. Okay? There's one thing, or I better let you know even right now at this level, because you guys are really good to learn things fast. Acids, okay? Acids are normally H plus. Okay, so know this. Acids are normally H plus. You get to hear of this when you get to year 11, but I thought let you know this. Acids are normally H plus. Okay, but alkalis are normally N and OH minus. Okay, so that's why we have NaOH. So know this difference. Okay, acids are always H plus. When they react in water, they form H plus. That's acids. But base normally form OH minus, the ions. Okay. Right. Let's continue. So know this difference. So what is a strong acid? We know this already. So acids that are not safe for us to handle. Those are what is known as the strong alkalies. Okay. What's a neutral substance? And you can probably make some notes here. A neutral substance. They are neither acidic or neither alkaline. So, for example, water. Water is a neutral. What is the pH of water? When you hear neutral, what pH would that be? You can type in the chat box for me. The pH for water. Listen to it. This is neutral. So, what pH would that be? What would be the pH? Correct? Yes, that's correct. 7. The pH for water is 7. It's neutral. Okay. Anyway, I'm going to be showing the pH scale shortly, so you can probably draw that as well when we get there. You've already seen this as well. Salt water, milk, saliva, and blood may slightly be acidic or alkaline. Okay. So be aware of this. It may be slightly acidic or alkaline. So know that neutral substance, they are neither acidic or alkaline. They can be neutral. That's the word, neutral. So they have pH of 7. Right. So acid and alkaline. Let's just identify what is this part here. What is this? Is it acid? What's lemon? Is lemon acid or alkaline? First one here. Is lemon acid or alkaline? Let's identify them. Acid. Well done. Well done. Excellent. Well done. Good. What about yeah, it's enough now. Right. What about Pepsodent? Toothpaste. Aquafresh. Is toothpaste an acid or alkaline? Yeah, toothpaste is an alkaline. Toothpaste is an alkaline. Okay, well done. It's an alkaline. Excellent. What about this? Ammonium hydroxide. You know that's what? What's ammonium hydroxide? What is it? Let me know. Ammonium hydroxide is what? It's acid. Well done. Acid. Good. What about this orange? Orange. Is it? Okay, let me now challenge you. Orange. Is it a weak or a strong acid? Is orange a weak or a strong acid? Is orange a weak or a strong acid? It's a weak acid, isn't it? Yeah, that's correct. Weak acid. Well done. Well done. Excellent. Excellent. Good stuff. Now let's go to the carbohydrate here. Is it a strong or a weak acid? We know that carbohydrate is acid, isn't it? Is it a strong or a weak acid? Strong acid. Good. Strong acid. Well done. Well done. Now, the bleach that we use at home. Let's identify what the bleach is. Is the bleach acid or alkali? The bleach acid or alkali? It's alkali. Is it a strong alkali or a weak alkali? Yes, it's alkali. Bleach is alkali. Yeah. Is it a strong alkali or a weak alkali? What do you think? It's a strong, isn't it? Yeah. Yeah, it's a strong alkali. When you smell bleach, you can feel that strong smell of it. So bleach is an alkali. Okay, very, very strong. Very, very strong. It's made of sodium peroxide. No, hydrogen peroxide. That's the name for it. Hydrogen peroxide. It's a very, very strong alkali. Our next one is this. Okay, then next one is water. We know water is neutral, so we won't spend much more time there. Water is neutral. Vinegar. Is it a strong acid or weak acid? Vinegar. 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 Yeah, it should be weak acid. That's why we eat it. So it's the weak acid. Remember, anything that's safe for us to eat, to touch, is weak. And everything that's not really safe for us to touch is strong. And we know the last one here, imperial letter soap. What is it? Is it a base or acid? Imperial letter soap. Is soap at the bottom here? What is it? Is it acid or alkaline? Soap here. Alkaline. Well done, Cortana. Excellent. Excellent stuff. So you all know your acid and base. That's good. Now a pH scale. A pH scale. Um, well done. A pH scale. I want you to draw this down. Or if you don't have color, just color it. Don't worry. Just draw their numbers. Okay? Write their numbers down. So draw this table. The pH scale. You know what the pH scale is. What is it then? What is it? Who can tell me the definition of a pH scale? I've just shown you this. And I say pH scale. You know, you're in your you're in year seven, or you have a brother or sister in year seven that you wanna explain to them what is it? What does this? What does this mean? What's a pH scale? What is it? What is a pH scale?